Good day, everybody. It's a nice hot day here in West Lafayette. Possible high temperature of 97 degrees, so probably be thankful you're not here because it's just too hot. Again, it's Professor Miller. So let me see if I can still remember how to spell my name this morning. And this is Theory Lecture 04, but make sure you use your correct naming convention. So whatever assignment that is, I don't know offhand. Last time we went over a problem that had inclined planes, and that was this one right here. And if you remember, an inclined plane appears as an edge. One view, planar here, same shape, same number of sides. Now today, let's look at one of your other problems, which is this one right here. Okay, this one here has an oblique surface on it. Okay, the red surface here. The green surfaces are frontal. The gray surfaces are horizontal. Okay, excuse me, the blue surfaces are horizontal and the gray surfaces are profile. So I want to look at this one here. And first off, I want to sketch it as an isometric sketch, develop it, and then we will sketch it out as an orthogonal view. My dimensions may not be exactly the same as the one here, but it will have the same general shape, okay? So again, this is a reminder, Theory Lecture 4 here. Okay, so I'm just going to start with a standard vantage point here, zoom out a little bit. Let's see here, it's 8 tall, so 2, 4, 6, 8. 8 from front to back. It is important or almost necessary to put the total construction rectangular prism in here to get this stuff done. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then 2, 4, 6, 8, 10, 12. You should be able to crank these isometric prismatic cubes out very, very, very rapidly at this point in time. So there we have it. We have that cube. Now if you look at it from the side view, okay, you look at it from the side, we're going to cut out a rectangular prism. We're going to make negative space out of that thing. So I'm going to come over here down, and over here, and up here, then bring this thing back all the way. Again, on isometrics, unless otherwise noted, you would assume that everything goes entirely through the object. So again, we have now that portion cut out. Again, showing you just this area in here cut out. Then I'm going to come through here, and I can't remember if my block's exactly the same as yours, but I'm going to come through here, and I'm going to then assume that this thing goes all the way through. So I'm going to cut this thing out here all the way through here. So if I'd shoot this thing back, it would hit. Okay, if I come back through here, you got to say, well, what is missing here? You know, what can you see? What can you not see? Okay, so if you go back, you know, to 2 back from here, so if I go here, bring that down to there, that cutout then is going to be hidden. Okay, that cutout on that side will be hidden. So now we've cut out this rectangular part of the object here. Okay, so now we have to put in the oblique plane. Remember, when you're talking about an oblique plane, it's going to be in your 3 views. It's going to appear as a plane, and a plane, and it will not appear as any edges. So in order to do that, you have to locate the endpoints of the plane. So we have to find this point here, this point here, this point here, and this point here. Well, this one is very, very easy. It's the front right bottom corner. Okay, so I'm going to label that point A. Okay, and the next one is on the very top, And it is 1, 2, 3, let's see here. I think it's, did I make it? Nah, I think it's 6. 1, 2, 3, 4, 5, 6 over here, okay? And so that point here connects down to there. So I'm going to bring that one down to this location right here, okay? The other one then is, I think it's, let's see here, 1, 2, 3, 4, 5, 6, 7, 8, I think over to here. And if it's not exactly right on yours, the same as yours, it will still fall apart and do the same way here. So that one goes to here. So now you can see I'm getting the incline surface built all again on this object here. So again, the last one then is needed to find this point right up here, and I think it is up 1, 2, 3, 4, bringing that to here, okay, and then bringing this thing down to here, okay, bringing it down to that location. Now let's see here, okay. So now I've been on. Now what I've noticed here, I've gotten on the very front of the object. Okay, I can find that point. I can find this point on the very back top. I can find this point on the very right-hand side, 4 up from the bottom, and I can come through there, okay? So now, we've got to look at what I'm going to term spatial relationships here. You have a frontal plane here, okay? It's cut by the incline, or excuse me, by the oblique plane. So notice on this that this line here and that line there are parallel, that line there and that line there are parallel. In other words, wherever, in this case here, this oblique plane, the red one, intersects a frontal surface here defined by point A, B, then all these lines that are cut by the oblique plane, or all these frontal planes that are cut by the oblique plane, will form parallel lines, okay? So I'm going to name this point C here, okay? And then we'll name this point D, E, F, and go back to A, okay? So with that said, okay, with that said, you know that this plane, that just like this edge here, that this one here goes back, okay? You're starting at this corner, it goes back into here as a hidden feature. So I'm going to put this thing as a hidden construction. Now notice on isometrics, you don't put in these dashed lines, but I'm doing this for construction purposes. Now we know that this point, or this line here, and this line coming off this back side of this have got to be parallel. So I'm going to bring this thing down, try to keep it somewhat parallel to right here, okay? And that line parallel there. So then we have then defined now this point right here, okay? That point there, and then we can do the same thing over here. Well, if you look, this point here and this point down in here are the same, or actually that'll define, they're 2 from the back towards the front, so then you get that surface going, or that plane going in that direction there, okay? And again, now that's defining the point right here. Now notice that if you sketch this somewhat accurately, this line, this line, this line, and this line are parallel with each other, okay? And I may be off a little bit because my thickness here, I'm going to make this just a little bit more accurate because my thickness looks to be too fat over there, so bring that to there, okay? So now we have some more points here. We have some more points we can define in here. F, and now we have G, okay? Now we have H right here, okay? So here's H, and then we have I over here. Okay, now let's look at this object here, okay? Let's look at this object. A goes back to B. B goes to C. C goes down to I, and then I goes over now to H. Let me get this straight on here. Same shape, okay? How many sides? 1, 2, 3, 4, 5. Again, 1, 2, 3, 4, 5. Kind of looks like a check mark, backwards check mark, maybe the Italy kind of backwards too, but again, it's gave that general shape here, okay? Has 5 sides. The other one then has D, E, GF, DE, GF has 4 sides, okay? And so then we can go ahead and build in this isometric and darken in the isometric at this point in time. Okay, so then coming over here, I'm going to then darken this in here, and here, and here. And of the isometric and orthographic sketches I've seen from a lot of you folks that you've turned in, they've been absolutely great sketches. So keep up the very, very good work. It's for me not being there to actually critique them. Personally, I've been super impressed with them. Okay, here, maybe you guys are doing better if I'm not around. And gals too. Back to here, over to here. Down here. The more you practice, the better you get. And again, I try to, once I get on a roll of going the same direction, I stay on that same direction here. And so then we have one here. Let's see here, this point goes down. This goes back to here. Okay, this goes down. This goes over to here. And this goes over there. This goes down to there, and that goes over to there. And if you look at that, shazam, we have the exact, or a good replication of what that thing actually looks like. Now let's go back here and let's make sure we didn't miss anything. Again, let's come back to here and say, oh. Now if you look there, again, if we look at this distance, 1, 2, 3, 4, 5, 6, if I count back 1, 2, 3, 4, 5, 6, and you're going to see that little cutout there. So again, don't forget to really double check these things. So then you're just going to see a little bit of that cutout over there, okay? So then there's the block. Again, now this one may not be exactly the same as yours, but it's very, very, very close. With that said, okay, with that said, now I'm going to take this thing and I'm going to construct it again. Okay, notice that if you go through here, and if you look at this thing from here, can you see my construction? You can see it vaguely, okay? You can see the stuff, but the idea is you can see what the object is, okay? You can very easily pick out what the object is, okay? So now let's go across here, and let me see if I can maybe put this over here. I'll have this as reference. I'm going to use the same sheet I used the other day, you know, as a environmentally safe move here, trying to use as much of this paper as I can at once. So again, over here, then I'm just going to start at this top left-hand corner, and again, I'm going to do my construction boxes. So again, let's do this one here. Let's try it. Okay, again, the 12 by 12 by 8, or the 8 by 8 by 12. Okay, so front to back, I'm on a top view. 2, 4, 6, and 8. 2, 4, 6, 8, 10, 12. And again, for this problem, you need to construct all of the constructions first, construction boxes, or you will have a very, very difficult time trying to figure this one out. Okay, through there, 2, 4, 6, 8 in height. And in my right side view is here, and then it goes back again. 8, 2, 4, 6, 8, goes up, goes over. Okay, so now let's take the easy ones here. Let's take the things that are very, very easy. Let's go in this view here, and again, let's construct the U out of here. So again, it goes from top, 2 from the bottom. It goes from front towards back up to there. Okay, in the front view, it just comes over here, and I want to zoom up a little bit on this thing, take advantage of this. Okay, in the front view, notice that that plane will appear as a dashed line. Dashed lines, not hidden lines. If you can see a hidden line, then I want to be your agent, because I've yet to ever see anything that's hidden or invisible. Okay, you'd be pretty special if you can see something hidden. You'd probably see things you didn't even want to see. So I'm going to go across here, because it goes from all the way from the right-hand side to the left-hand side, and from the left-hand side to the right-hand side. So now it's just as if this thing's a U, just cut right out of there. Okay, again, you cannot see that edge, but that horizontal plane, but it is there. So then let's go through here and let's cut out this part of it, right in here. Okay, and now with that cut out, you know there's got to be a dash line here and here, a dash line there and there. With that being cut out here, it's got to be a dash line here and here, there and there. Take one feature at a time. Notice I did this entire negative cutout here of this prism. I found where it was here. I found where it was there. I took this front cutout here, and I found where it was there and there. Okay, because in between there is nothing for it to intersect with. Over here, from front to that, back of that, and then airspace, and from there back to the total back. Again, now let's look at the actual the oblique plane again. Okay, so I think I said on my oblique plane it started here. I think I put mine at 6, which may not be exactly the same as yours, but I'm going to keep it consistent. Okay, yours may be a little bit different dimensions, so I'm going to go 1, 2, 3, 4, 5, 6. Okay, I'm going to define point B. Well, let's put point A in there right away. We know where A is. It's on the bottom front right. A is there, bottom right, okay, front right, and then front bottom. There's point A. Point B, 1, 2, 3, 4, 5, 6. Right here is point B. Point B is at the very top, so here's B here, and point B is on the very front of the object. So then here's point B right here. And then we know that A connects to B. So we already got A connected to B here. Make this a little darker. We already have A connected to B here, but now we have to connect A to B right here. It's on the very front of the object. Okay? So then what was the next point we found? Well, looking at this, we went from B clear back to point E. Okay, and again, I'll superimpose this. Here's B back to E, B back to E. So we have B here, and then E was, how many blocks did I count? I think 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so then there's 6, and here is 8. So there then is point E. E again is on the very top, back. Well, here's the top. Here we can't tell front to back, but we know that E has to be there. And we also know that E has to be on the top back. So right over here is E at this point here. So now connect lightly. Line segment BE. B goes back to E. B goes to E over here. Again, you can't tell across the top. And B goes to E right in here. So we have some of those in there. Then we went down and we found this point right here. Get this over here so you can see it. This point right here. You find that as point F. Point F here. F's on the very back. It's 1, 2, 3, 4 up from the top. So here then is on the very back, 4 up to the top. So this is point F. Okay, in the front view, you will see point F directly on what? The right-hand side, 4 up from the bottom. 1, 2, 3, 4, here's point F. And on the very back, F is right here. So now we know what? We know that E goes to F. Okay, E goes to F here, and then right here, E goes to F. And the relationship between this line and this line should be parallel. And it doesn't look real parallel to me. What did I do wrong here? E to F. 1, 2, 3, 4. 1, 2, 3, 4. Okay, let's see here. E to F, E to F. Point E to F here. One of these has just got to be off a little bit. Now, which one of these is probably this one of all of them. Let me just see if I can make this thing a little bit straighter. And that comes over then 2, right? Okay, not a very parallel line here. Let me double check my dimensions. So again, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. There's E. F is on the very right-hand side. F is on the very right-hand side, 4 down. Here, it's just, I'm just off a little bit with my sketch. Okay. Then F connected back to A. Okay, F then is down to A here. F is on the right-hand side to A here. And then in this view, you can see F right back connecting to A. Okay, so F to A there. So now we're trying to develop, in this view, we have both oblique surfaces shown. Okay, so then we named this point right here G. Name this point H. Name this point I. Name this point C. Name this point D in this view. So now let's go ahead and put the oblique plane in this view. Just going to highlight the oblique plane. It goes from there to there. H. I goes to H. H goes back to A. Okay. A to B, B to C, C to I to H, H to A. A to B, B to C, C to I to H back to A. There's the oblique surface. How many sides does it have? The 5 sides. Does it looks like this plane here? Yes. Remember, oblique planes are going to appear as planes in all the 3 principal views. You're going to have the same number of sides. In this case, it's going to have 5. It's going to have the same general shape as the one we have here. Okay, as the one we have here. So now let's go through and put some points on here. Okay, this is point C. This is point D. Let me scoot this down a little bit. Okay, this is point G. Okay, point H. Now, where is point I? Okay, where is I? Well, you know that I has to be along this line here somewhere. Okay, we know that I has to be along here somewhere. So we have to define where I is. But now if you look over here, we know that this line, because the oblique plane intersecting the frontal plane, and this and this and this are all parallel, so I know where C is at. So I can project C down to I in this view. Because I know where C is, so I got C here, I project C down to here, here is C, and if it's parallel to these other lines, so I'm going to come down right in here. Okay, and then this, where it hits at this level, 2 up from the bottom, 2 up from the bottom, defines point I right here. I then goes back to H, I goes back over to H to the right, then H goes to A. So now in this view here, in this view you have then, let's define it, A goes to B, B goes to C, C goes to I goes to H goes to A. A to B, line right here. B to then C, right there. C to I, right here. I to H, right there. H to A, right there. Same number of sides, 5 sides, generally the same shape. Okay, generally the same shape. Okay, top view. Okay, let's stay on the front of this thing here on the top. Let's stay with this B to C to I to H to A to B. Okay, so then in the top view, we also know what? Well, we have then, the top view, we have point B, we have point C, H, A, and B. But we need point I. Well, now we know where I is. I project straight up to right here. Now I've got this, H is mislabeled here, folks. I messed that up. I shouldn't have put that there. H is 1, 2, 3, 4 from the back. 1, 2, 3. Here should be H. But now we know this point is I. Again, the same thing here. I goes to H goes to A goes to B goes to C goes back to I. You have the oblique plane shown in that view. It is 5-sided and it's the same general shape. Here, to there, to there, to here, to there. There is that same general boot shape. So we have the oblique plane shown in that view. And we are happy, 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 okay? So now let's do the other planes here. Well, the other one is very easy. D goes to E. So I'm going to darken them up where I see them at now. D goes to E goes to F goes to G goes back to D. Same thing here. D to G to F to E, D to E, okay? Then we need to know what? Well, where is that plane at in this view, in the front view? Well, again, if you look at parallelism, we know where point D is. So if we project that down, we will be able to find a point G in the front view. Okay, excuse me, right in here. Oh, excuse me, right here, I'm sorry, right there. Again, we're going from D to projecting down to finding then G. And we have parallelism again working here. Excuse me. So we have then D projecting it down to right here. Okay. And then that's going to go all the way to what? It's going to go to G, which is on the right-hand side. So you bring that down to, let me turn my clipboard here a little bit. Goes to that, and then that defines what? Point G, which is right over here. I'm off some. Okay, it should be down a little bit more. Okay, here is, see, we can project G over. We can project G over to here. So I'm off some. So let's take this down and clean it up a little bit. E goes, or excuse me, D. Let me get D labeled on here. There's D. D goes to G. And then, again, not super accurate, but let me clean this one up here just a little bit. So right in here is the inclined plane. 4 sides and all the views labeled. So now, well, we still have to put this entire plane in here. So again, just cleaning this thing up, it's going to go to here, to here, to there, to there, to there, across to here, okay? And again, we have some hidden features in here. I put a little dash right in there because that thing stops being seen. Now, again, the top view. There, across to here, to there. We can see that. Dash line, dash line. Again, dash line is not hidden. We're thinking, think 3D, man. Okay, line across here. What else do we need? We need a line across here, right? Okay, forgot that one a minute ago. We need one across here. This one goes down to here. This one comes over and makes the U shape. If you take these things and break them down into simplified steps, these problems fall apart. You look at this thing, you're going, whoa, you know, how am I ever going to sketch this thing, okay? Well, it's not that difficult if you break it down and you think about, you know, what's the relationship? Well, this oblique plane, wherever it hits a horizontal plane, this has got to be parallel. Wherever it's a profile plane, that and that have to be parallel. Where it hits a frontal plane, that and that have to be parallel. If you think about parallelism with these things, you break it down, make the whole entire instruction, then start taking things out of it. You know, we took this U shape out, which went across here, then we took it out here. Then we cut this thing out in here and there, and then now when you review that, then I just noticed that what? I missed a dash line there and there, there and there, okay? If you use labeling techniques, it helps. Okay, find a point you know. We know we're B, E, F, okay? We're at A in all the views, construct those things out, look at what the thing looks like, and kind of carry on from there. So they actually do fall apart pretty easily, okay? Now, let's talk about some other things here, okay? I am now just going to go out and I'm going to sketch a prism, okay? Make this thing, make sure I'm on the page here. Maybe zoom down a little bit more. That's about as good as I'm going to get. So 2, 4, I'm going to make this 6. Why? Always keep it even increments because they're easy to work with. You're not cutting blocks in half. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. That 1, 2, 3, 4, 5, 6. And let's make it, I don't know, let's make it, am I on the screen? Yes. Let's start here. Let's go down 3 and let's put it here and go down to right here. So let me see how tall that make it. 2, 4, 6, 8. Okay, so I've just made 2 constructions in there. Again, here, across to here, here, here. Okay. So what am I doing? I'm making a circle. And that one actually didn't turn out too bad. So if that's a circle, the circle makes it a prism. I have my center point here. You have to have your axis in this view. So now I have a positive cylinder. Okay, it has a positive cylinder in here. So then I'm going to go ahead and darken this thing up to here, to there, to here, to there, that, and then see if I can keep from ruining my pretty good circle up here when I go over it with the ink pen. A little lopsided there. Do not forget your center lines. Do your center lines correctly. Look at the readings. Okay? Now, I want to talk about different holes. Different negative cylinders in geometry. The first one I'm going to talk about is a through hole. Okay, a through hole, let's just make it a diameter of 2 here, goes entirely through the object. So it starts from top and goes to bottom. Okay, it starts at top and goes to bottom. So then we'd have to go, so now let's go ahead and dimension this feature here again, okay? So again, this is a positive cylinder, so I'm putting the diameter symbol between the views whenever possible. And on positive geometry, you put the dimensions between the views and you put the diameter symbol on the rectangular feature. On a negative cylinder, you put the annotation, which is annotation is non-graphic stuff on drawings, engineering graphics, and you would just put the diameter here. Okay, the arrow is pointing towards the center of this thing, right out in that direction there. Okay, so now I'm just going to use S and L. Okay, I'm just going to use S and L. So my S and L, so S is equal to size, and L is equal to location. And what I'm talking about in a CAD program would be referred to dimensional constraints. In standard engineering drawing, we're talking about just dimensions. But now notice when you would go to build this thing in, let's say, CATIA, you could make a circle here of a diameter some size, and you would give it some kind of extrusion value, which would be the height. Let's go ahead and put the value over here. So this would be size, because you're sizing the cylinder. And then we would have to give it a size here for that small one. So I'm just going to put size. I'm not worried about numbers now. The reason I'm not worried about numbers because in a constraint-based package, you wouldn't have to worry about that. You just put a number in there. It's just easier than counting blocks. So I'm putting diameter size. The size actually would have been what? Diameter of 1, 2, 3, 4, 5, 6. Okay, we're just practicing dimension. We're not too concerned about the numbers. So now if this hole as soon as we go all the way through, that's all that would be all the actual annotation you'd have to give it. So it's just a through hole. But now let's go through here and let's say that this hole actually now does not go all the way through the object. It actually does not go all the way through the object. Okay? It's called a blind hole. So let's say it goes, you know, let's say it just goes 4 blocks down and stops. Okay? So now this dashed line is no longer here because now we're just saying that the hole goes down 1, 2, 3, 4, and again this would be an L shape right in here, and it actually stops. Well, then you have to tell the person what the distance is going from top towards bottom. Okay, so in this time we're going to go then, this thing looks like an anchor, but it's got a arrow on the bottom of it. That's going to be size again, and what that's telling you is the depth. Here's the diameter of this thing, and here's the depth it's going down in. Okay, that's the depth that's going down in. Those type, so first off we had the through hole, okay, and you'll see that a lot of times in older drawings just as annotated with the word through. Okay, in that respect, the next one is a blind. You have to have a given distance, so that's what this is telling you here. Okay, so those are two different. Now let's talk a little bit about a blind hole. If you would use a drill and actually drill this thing into here, you would have something that would look like this. It would come down your cylinder and then it would come to a point. The size of these holes are only the depth of the cylindrical part, not the conical. So that is your size. Again, darken it in so you can see it better. That would be my size, the cylindrical part. The conical part is not sized. There's my axis. There's my size right here. Okay, so then what this is saying here is this is going down this depth, whatever it is. In our case, it's 1, 2, 3, 4. That's the size here. So again, that's a blind hole. That is a blind hole. Now let's even go further here and let's make another one called a counterbore hole. Okay, a counterbore hole. And I want to make it, it's going to be another hole right on top of this. So again, if I would come in here in this view, it's just another hole going right across the top of this thing here. So my construction end is going to be up here. And I'm going to make another circle right in there. Remember, circles don't have flat sides, and that top left-hand quadrant of that circle is not so good on the outside. Let's see if I can do a better job here. The quicker I do it, the better I am. So now, okay, now we're forming what's called a counterbore hole. Okay, so then what we have now is this comes off, this becomes an L shape. And now if we just had this hole right in here, just a counterbore hole, it would go from one side all the way across. You'd still have to show this surface back in here. But now notice this has also got it's got the blind hole in here. So you're saying diameter size, the depth of size here. But now this part of this blind hole has been cut out. That forms a T, that forms a T, that forms an L, that forms an L, a dashed line across there. Now you've actually gone through and made this counterbore hole. Okay, you've made the counterbore hole. Okay, but now we have to tell somebody the sizing of the hole. Okay, so now I'm going to move this one up just a shade here, erase this thing off. And now I'm going to point this to the outside since I've made this here. So I'm going to go over here, bring that over, point it to this one, the first counter one. So now what we're saying is the smallest hole, the tap or the pilot hole, is a diameter of size. It has a depth of size. So again, that's a small one right in here. But now we've made another negative cylinder in here. And now that's going to be called a U for counterbore diameter of size. That's your diameter right here. And then you have to give it a depth of size. So now you size this cylinder. There's your diameter. In this case, the depth was 2. Okay? So basically, this is the whole annotation. I kind of got it spread out, but it'd be first hole is a small one, diameter size goes down 4. Then the U for counterbore is here. Diameter size goes down, in this case, 2. Okay, so that is what a lot of times you'll see in the past they refer to as a C-bore hole. Again, we've gotten totally away from the language thing because it creates a language barrier. You know, you guys in China try to get me to read some Mandarin Chinese, and I'm not going to be able to do it. Okay, thus the reasons why we've tried with the global economy and so on. We've tried to make this all language independent. Now, there's things you can't get away from, but a lot of it you can avoid. So that's counterbore hole. Okay. Now let's think about, and let's make another cylinder over here. Again, I'm using as much room as I can on this sheet. I'm going to do the same thing here. Again, I want to make it, let me go ahead and, one thing here, while I'm here, let me go ahead and darken this in so I don't get delinquent. Okay, well, I am delinquent, just in darkening this in anyways here. Size, my arrows, keep your arrows simple. Okay, keep them simple. This makes life simpler. So you have arrows popping in your head. Okay, one more here, the countersunk hole. Okay, a countersunk hole. Well, again, I'm going to skip back to here. The reason why you do counterbore holes, you want to drop something in this hole that will not have stick above here. So let's say you put a fastener here, a cap screw. You would drop that in here, and you want that thing to be below the surface of the object or flush with the surface of the object so something could clear that. Okay? So that's why you use a counterbore hole. Now let's go and let's make a countersunk hole. Again, I'm going to make a cylinder that is 6 by 6. So let's go over here and move my page up here a little bit. Make sure I don't get it too far up there. That looks pretty good about right there. So 2, 4, 6, 2, 4, 6. And again, I'm just going to make this a little bit shorter. Here's my axis. Excuse me, let's put my construction line in here first. Construction lines, again, you can make circles appear as circles. If you have to take your time, put more construction lines, then please do so. I'm going to get really brave here, and I'm going to do this thing as a, this is a circle right down here first. Let's see if I can do it any better, just quickly. The quicker I do them, typically the better off they are. So again, here to there, back over to here. There's my axis in here. Okay, and my axis right here. Positive cylinder. Again, you would size it. We've done it once over here, there and there. We don't have to do that again over here. All I'm going to be worried about this time is the countersunk hole. Now, like the counterbore hole, the countersunk hole has an initial hole right in here. That hole goes all the way through. It is just a value. If it doesn't, you have to put a depth value. So again, I'm going to start over here. I'm going to say, well, that would be the hole that would go right through here. And so then I'm going to go ahead and put my other circle in here for the actual counterbore itself. Ooh, ugly. Okay. So now I'm going to go from the outside and pointing towards the center point. I'm going diameter of size. That's a small hole. Diameter size on that small hole. Now again, if there's no depth symbol below that, you're assuming that that hole goes all the way through. So you're assuming without anything below it that this hole goes all the way through. It's not blind, it goes all the way through. But now we're going to make this thing into a counter sunk hole. So again, putting my other outside circle in here. Okay. Now the counter sunk hole is conical. So projecting this down here, projecting this down here, and then you could say, okay, let's just say it goes down from here to there, and then from up there to there. So darken this thing in. We have a line. This is the ones that, this is kind of making a Y shape, okay? Kind of a Y shape there, but then you have that dashed line that goes across, dashes here. Like these dashes, they're not dots. Make sure they're visible in there. So now there then is the countersunk hole in that view. I kind of got a little bit rounded there. So now what is the annotation for it? Okay. You're going to go here, V, diameter, times, let's say, 81 degrees, the included angle. I'm not going to get into this, but what they're saying is this is for countersunk, this is your diameter. It's 4, okay? Times 81 degrees defines it. So again, that is called a countersunk hole. So in review, we went through and we basically went through how to do an oblique plane here, okay? We then, let me zoom out a little bit. Then we came over here and we talked about cylinders. In this case, blind holes, counterbore holes, the correct annotation here. And then finally, over here, we talked about countersunk holes. And with that said, we are done with this theory lecture number 4. And thank you very much. Have a nice day, evening, whatever it is in your part of the world.